Working our way through the problem set. Alright, let's take a look at what do we got here. We got 20 is greater than or equal to, you could say, 5 times the absolute value of x minus 7 minus 8. Okay, so our goal is to get it into the form that we've been talking about, that absolute value of AB plus AX plus B, that's the absolute value of, right, is greater than or equal to C, or something like that. What do we want to do? Well, let's take the 8 over to the, let's take it over to the left over there. So we have 20 minus, no, plus 8 is greater than or equal to 5 times the absolute value of x minus 7. Right. So we end up getting 28 is greater than or equal to 5 times the absolute value of x minus 7. We're getting there. Multiplying both sides by the reciprocal of 5, which is 1/5, we end up with 28 over 5 is greater than or equal to the absolute value of x minus 7. Now what I'm going to do here is I'm going to go ahead and get this back into a form you're more familiar with, putting the absolute value on the left side of our inequality. Now we got it into the standard form that we were trying to achieve, and now we want to determine if this is an and or an or. Well, it's pointing to the left. So remember, if it's pointing to the right, it's an or. But because it's pointing to the left, we're looking at and. Okay, so what we want to do now is drop those absolute value bars. That is x minus 7. Almost looks like an inequality. Now remember, it's going to be an and. And so let's now rewrite the right one, x minus 7. We want to flip that inequality and make that a negative 28 over 5. So now it's just a matter of solving the inequality. So we have x is less than or equal to 28 over 5. Because that's a minus 7, we take it to the right, it becomes plus 7. Right. And now what we'll want to do is get that all into one fraction. 28 over 5 plus 7. Right, you know, you get a common denominator, all that stuff. Whoops. 28 over 5 plus 7. And I'm getting x is less than or equal to 63 over 5. And I'm going to approximate that so we know we're about on the number line where we need to put that. So this is actually 12.6. Gives me a better idea on the number line where I need to put that. Okay, bringing the and down. So we have x is greater than or equal to negative 28 over 5. Bring the 7 over to the right, makes it a plus 7. So we have x is greater than or equal to, right, so we got 7, you could say 7 minus 28 over 5, which is going to give us 7/5. Or the let's see, didn't go in 1. I think 1.4, something like that. All right, now remember, and it's a big deal. Let's go ahead and draw the number line. Okay. Putting arrows on indicating it's going in both directions on forever. Alright. So we have 12.6, 1.4. So we're going to say that, what are we going to say? We're going to say that we're going to arbitrarily pick 63/5 to be over here. Okay, and 7/5, we'll just pick it to be over here. How's that? Just pick a point. Alright, this one here, we'll use this color. X is less than or equal to, so that means we're going to include it. And it's everything less than. That's going off in that direction to infinity. And now x is greater than or equal to 7/5, right? Going off in that direction to infinity. But what is key here is this word and. And means that when we pick a point on the number line for one of our solutions, it's got to be both in this set and in this set here. You see? And the only place that that's going to take place is the intersection. The intersection. And so writing our interval, writing an interval notation between 7/5 and 63/5. Okay, it's got to be in here. That point must be in here in order to make this a true statement. Okay. All right. Also, we could write x is greater than or equal to 7/5 and less than or equal to 63/5. Okay, either way. All right, see you at my channel in the next problem.